Recording in progress. And chapter 3 is all about looks and sound. We're going to need some of the pre-started Scratch projects from the website. If you didn't already download the chapter scripts, there's a link here to go get the chapter scripts and download them right now if you need them, and you're going to need a few of them today. We're going to make a new Google Drive folder called chapter 3, and in there we're going to make a chapter 3 practice. So let's just get that done right now. Get that assignment started. And inside your chapter 3 folder. And again, I know some of you like to go to Google Docs to start stuff. I like to start things in Google Drive because then they end up in the right spot. I don't have to worry about moving them later. So from my Google Drive inside my CS160 chapter 3 folder, then I'm going to go new Google Doc, create and share, and then it ends up in the right spot. So I don't have to worry about moving it later. And this one's going to be called chapter 3 practice. And then right away, some things I'm going to need from here. I'm just going to grab questions 1 and 2 for now. And I should just be able to copy questions 1 and 2 from the assignment page and paste them in. But I want to put a title at the top. Anybody remember how in a numbered list to get a new blank line underneath? Shift enter. Yeah, shift enter. So if at the end of line 1, I use shift and then enter on my keyboard, it's going to give me a new blank line. I can type my answer. If you want to put a little more space in there, put another shift enter in there. And eventually you can put an answer to that there. I'm going to do that after question number 2. So at the end of question number 2, remember, if you just hit enter, it gives you a new number. And 3 is an okay thing to have because eventually the assignment says number 3 should be for me to play with the traffic light assignment from the book. So we'll get to that. So since I hit enter and I have a 3, I'm just going to type traffic light there. We'll get to that in just a minute. And then back at the end of line 2, what I meant to do was shift enter to get a blank line for me to type an answer. And I'm going to put in a few blank lines. And I'm not copying and pasting all of this because sometimes when you copy and paste things from a website to a word processor, the word processor doesn't quite see it the same way and weird shit happens. Like last class, I had to do a bunch of editing after the copy and paste. It was a pain in the butt. So let's see, I'm going to do traffic light, argue layers next. So traffic light, enter. We're going to get argue in there. And then we're going to get layers in there. What else are we going to do today? We're going to do the volume demo and the dancing on stage, and we might get through all of this today. So volume demo. Now let's blow this sucker up a little bit. That's better. And then what was the last one? Dancing on stage. I think it was dancing on stage. And eventually I'm going to make each of these 3, 4, 5, 6, 7 links to my Scratch projects that I'm going to play with. Has anyone already started the reading and know what a costume is? What is it?
It's another sprite that's assigned to a sprite object. It's really confusing to think about.
Yeah, that's a way to think about it.
It's confusing to think about.
Yeah, so
different images.
So like I could be a sprite, right? Was I wearing the same thing last class? No, I was wearing something slightly different, right? It was clothes, but it wasn't the same clothes. So I had a different costume on last class than this class, but it's still me. So any sprite that you use can potentially have a bunch of costumes, and all those costumes are basically graphics of that sprite. Now, could the graphics be very, very different? Sure, they could, right? I could replace in my sprite a graphic of the Hulk, and I turn into the Hulk, but it's still me. Okay, you can do stuff like that, right? So they're essentially images to represent whatever sprite you're playing with.
I've noticed if you upload like a GIF that has multiple frames in it, it'll upload them all.
Ooh,
as
does it?
costumes sequentially.
Oh, that's
And you
cool.
can animate them if you repeat next costume.
Next costume. Oh, nice. Okay, so that's cool. I didn't know this. So GIF is a graphics file format, and GIF has a feature where you can animate it. And an animated GIF means there's a ton of different versions of that GIF, and the computer will know if the GIF has the animation setting and a bunch of images inside of it to cycle through them to make it look like some kind of action is going on, which is kind of cool.
And Scratch just uploads each of them as a separate.
And Scratch, if you upload an animated GIF, then what Scratch is doing, you're telling me, is it just separates that animated GIF into all of the images as costumes.
Yeah, it'll be all the costumes under one sprite.
That is so cool.
That's
That is cool. I didn't know it did that.
I just found that out when I was experimenting with Apache.
Yeah, and here's, I've been using Scratch for years with college students, with high school students, with elementary school students. I learn something new all the time about it. And they're always introducing new features too. So anybody that does programming learns after a while that every language they play with, they learn something new about it every time. Nobody is an expert in any particular language, in that they can't possibly know everything about the language because they're always in development. Just kind of cool. So it's a field you'll never get bored in my opinion. All right, let's start playing around. First, did anyone not get their book yet? In the room, how many people we got? 1, 2. Okay, so that means if your hand is not up, you definitely have your book. Okay, on Zoom, is there anyone that doesn't have a book? Those yups just come in. No, that was earlier. Yeah, nobody on Zoom. What's up?
What assignment is the link to the files on again?
What assignment is the link to the file?
Yeah, the Scratch files.
Oh, where do you find like the
Yeah,
chapter
the chapter.
scripts? Okay, so I put a link to them here in the assignment I'm playing with now. So I'm in the chapter 3 reading assignment. And in there, the third paragraph down here has a link to the chapter scripts.
If you ever need them, I got them all on USB.
Excellent. USB, carry it around. I used to carry one around everywhere. I don't as much anymore. Yeah, so if you don't have the chapter scripts at the computer you're at the moment, in the chapter 3 reading assignment, you can click here. And that'll take you automatically to the download link from the Scratch website, and you can grab those chapter scripts. And we're going to need those. Okay. All right. So what is a costume and how do I change it? Let's go into Scratch, and I am just going to create a new one. And with all the playing we do in this class, I find, because I'm always opening something to screw around, to check something, I end up with a lot of untitles in my stuff. And then like every week I go back and just delete any untitled stuff that doesn't have useful stuff in it, if that makes any sense. And I'll probably demo that later. So like if I check out the cat right here, there's the code tab, which shows me all the code options. Next to it is the costume tab. And I can see the cat sprite comes with 2 costumes. And each sprite that comes in the system, they vary. Some only have 1 costume, some might have 10. It just kind of depends on the sprite. How do we use costumes? Well, we use costumes by going to the looks group of buttons, and then there's some costume related things like switch to costume, whatever, choose the next costume, and backdrops actually have, backdrops have different costumes themselves. They're just called backdrops. And you can change those too. So the background can change when something happens on the screen. All right, question number 1 is mostly answered. What's the difference between play sound and play sound until done? We're not into sound yet. We'll get to that later. All right, let's check out the traffic light. I think is next. Yes. So if you don't have the book, by the way, I have one here that people can borrow, and I'll put one in the library. And if it's not going to come this week, then please send me a message through Canvas saying my book's not going to come this week, and I will let you borrow a digital version of my chapter 3 for now, so that you can get stuff done this week. So again, if you don't have the book yet, if you're not going to get it this week, then send me a note through Canvas saying, I'm not going to get the book this week, and I will respond and let you borrow a digital copy of my chapter 3. And you have to promise to not give it to anyone else and destroy it when you're done. All right, so let's see. Traffic light, I have to upload. So since I have the chapter scripts, I'm going to go to load from your computer. And I'm going to go find my chapter scripts. And now I'm in chapter 3. And I want the traffic light. Yes, I want to replace this. And keep in mind my warning about upload from your computer, because that can overwrite a script you're working on. So you do want to start with a blank script when you do that. Another warning, which a couple of people emailed me about. On my computer, oops, wrong button. There we go. I have files. Let's see, where did I put them? I think they're in my downloads, maybe. CS160. Yeah, there's my chapter scripts. And there's my chapter scripts again. How do we run Scratch programs? Well, I go to scratch.mit.com or edu, something like that, and I run them there. Scratch.mit.whatever does not live on my computer. So if on my file explorer, I try to double click one of these, the computer's like, I don't know what to do with this, because Scratch software doesn't run on my computer natively. Now, there is a Scratch app. You can download your computer and run shit offline. So if I had that downloaded, I don't know if I do on this computer, we'll find out, then the computer should try to open it with the Scratch app. Clearly, I don't have the Scratch app installed because it says Windows can't open this file. Some versions of Windows will realize that a Scratch file is really a zip file with the extension SB2 or SB3, and it will try to unzip it and show you everything inside of it, which can be a little strange. So point is, the only way you can use downloaded Scratch files is to upload them to Scratch, unless you've installed the Scratch app on your computer. I hope that makes sense. Okay. Go away. Go away. Oh, I broke it. There we go. All right, so with the traffic light, it's set to do something. So when the flag is clicked, forever switch costumes. Nothing's happening. Actually, stuff is happening, but it's happening so fast, the display really can't keep up. Okay, so in lesson 3.1, if you don't have the book, I'll read it to you. It says, go grab this file, check out the costumes that it has. Oh, I didn't do that yet. Stop. Costumes. All right, so there is a red costume and a orange costume and a green costume. Cool. So now when I go back to the code, I can see it says switch to costume red, switch to costume orange, switch to costume green. So it's going to cycle through those costumes. But again, with the forever, it's doing it so fast, I'm really not seeing anything interesting. So I'm next told to complete the application by adding necessary wait blocks to create a realistic traffic light animation. All right, let's give it a try. So let's see. That's either events or control. It's control. There's a wait 1 second block. And so what I'm going to do is I'm just going to grab that and I'm going to stick it after red. I'm going to grab another one. I'm going to stick it after orange. I'm going to grab another one. I'm going to stick it after green. And a lot of times when I run code, I have an idea and I just test it to see how it looks. It may not be polished yet. So every second it's going to do that cycle, waiting a second in between. Is that how traffic lights work? Okay, so that's not realistic. Okay, so I'm just gonna shut up for a minute and hopefully you're in your traffic light app and you are about to put some weights in there. Now you're about to put some times in there that make it more realistic. So I'm gonna pause and let you play for a minute. If anybody has a question, like you're having trouble getting this on your screen right now, wave me over. If you're online, chat me a question. Yeah, I've been at some long, it always seems longer than it is. Occasionally I do a stopwatch at red lights.
Faulty wiring.
You got, oh, it's doing fun stuff. Well, it's realistic, you need to wait 10 hours or
Also,
and make it realistic when you have like a little top pager, like make it just stay.
That would be fun. Yeah, all those TV shows where you see people hacking streetlights, it does not work like that. Somebody can't get on a computer and start typing shit randomly, even on purpose, and then make a bunch of traffic lights change. That would take weeks of setup, and the implementation of it would not be instantaneous like that. So almost everything you see about computer hackers in movies is completely unrealistic and untrue.
In Watch Dogs, they explain it away where like the entire infrastructure is replaced with something that can be done with that, but in everything else, I
can't.
No.
All right, so let's see. I get to a red light and I'm gonna say I'm probably gonna have to wait. 10 seconds seems like a long time, but maybe it's 10 seconds. I'm too impatient to wait that long in class because I got other shit I want to do with you. So I'm gonna knock it down to 5. Orange, if red is 5, let's say orange is 1, speeding up time a little bit. And then the green, I'm hoping it's at least as long as the red. So I'm gonna put a 5 again. Okay, so this is not completely realistic, but this is like maybe what, double time reality at some places, right? So the red hangs for a little bit.
But it also depends on the intersection.
It depends on intersections, and some intersections are programmed to measure traffic by the weight of things going by and the speed they go by.
Size of it, how the height,
And then there's some places where you have like you push for the crosswalk. In Pendleton, none of them work. It's all an illusion. They just put them there to make you feel like you're making progress. Okay.
light anywhere.
So this is going to happen a lot in apps that we make. The speed at which things happen in the processor are too quick. And one way we can slow them down is by throwing a weight inside of our script somewhere. Okay. So, all right. And we get to change costumes. Is there a different way I could have done this? Anybody?
Start with the green.
To make it realistic?
Go for
So-
red, green, and
Yeah, I could change the order of them for sure. I was thinking, ooh, this is a way I could do it, but I'm not sure it's realistic. I could put in the forever, and then for the looks, I could put in next costume, and then I could throw in a weight. But the problem is with this is the next costume block doesn't really, it just knows there's a next costume. It doesn't know which one it is. So I can't really make them different times with this approach right here, right? So given that each one needs its own time, I really do need to have specific references to the costume I want along with the time I want to have with it, right? To make it more realistic, there's really no way around that. Okay, I have to stick them together. Okay. So this right here would behave the same way as if I put one for each of these. So this forever next costume, wait 1 second is exactly the same as this. But again, if you want them to each have their own individual time, this would be a bad way to do it. And I'm just going to take it away. All right. So I did the traffic light here. I'm ready to share it. It's now shared. I'm ready to copy the link. And now we don't, in a Google Doc, we don't want the embed link. Google Doc can't do that. I'm 95% sure it can't. There may be a way to trick it into doing it, but off the top of my head, I don't know what it is. So I'm just going to copy the regular link. And then in my Google Doc, I'm going to highlight the phrase traffic light, and I'm going to use the link button and paste in what I just copied and apply it. So now when I go look at your file, all I have to do is click on that and it's going to take me to your version of it and I can see it doing however you program to do it. Okay. Question about sharing and linking in Scratch and Google. Now, I mentioned the other day that I've accidentally overwritten files by dragging another one from my computer on top of it, which once I had lost a lot of work. I've also had students that got locked out of their Scratch accounts for some reason I couldn't comprehend, and they lost all of their files. So it's not a bad idea if you have an important file to you, back it up. So to back up a Scratch file, your only way you can do that is from the project, see inside, you would have to save it to your computer and put it somewhere you'll remember. So I'm just going to right now, you don't have to do this. I know some of you already have done this based on some things I saw coming in. I'm going to put a chapter 3 folder here. And in my chapter 3 folder, I'm going to change the name actually to Gary's traffic lights. Not to confuse it with the traffic light I have in my scripts, which is a slightly different version of this now. And if I wanted to, I have a backup of it on this computer. I might also put it in my Google Drive so I can access it somewhere else, or maybe on a flash drive, whatever. Okay. So there will be times when I'll say, please download your script, put it in your drive for me. You don't have to do that for this one right here, but that's how I do it. And again, if I want it in my Google Drive, hang on one second, I'm getting there. Oh, I still have an untitled document. I thought I titled it. Google just hasn't picked up on it yet. I could, if I want, upload it here. Just file upload right there. You do not have to do this right now for this assignment. All right, question.
Actually, two things.
Yeah.
One, I actually learned you can just drag and drop into the Google Drives.
Yes, you can.
But
Yeah.
also, saving it to the Scratch, there's only so many that it'll save before it just starts automatically deleting them when you're saving them.
Oh, Scratch only gives you so much storage and then you lose them. Okay, I have not exhausted my Scratch storage yet, so I haven't run across that limit, but I imagine most
Yeah, 'cause
places do that.
I've just been playing around with some of it, and then
Yeah.
when I looked back to go grab something else from a previous one, it wasn't even in there.
So the only time okay, so I have seen that happen before, but it's rare. Usually the only time you lose a file like that is if you actually, like right now, if I open up another file on top of this one, I will lose traffic light. It'll disappear from my Scratch holdings. But I'm just going to switch over to show you my stuff. So Scratch loads, I don't know, maybe 20 scripts at a time. Looks like more than that. Maybe there's 30, 40, a lot. And so if I click load more, it's going to load like 20, 30, 40 more. And you can see I've got a lot of Scratch scripts I've been collecting for the last, I don't know, 5 or 6 years now. And some of them are very redundant.
Yeah, I kept saving mine, no matter what I did, it just kept deleting them.
Yeah, that's weird. It's because I have no special Scratch account. I just have a standard Scratch account, and it's been saving mine for years, and I have hundreds. Okay, so if it happens again, then I'm going to help you try and investigate and see what's going on. Okay.
I just started saving it to my computer.
Okay. All right, let's try another one. Next thing I wanted to do is try it out, number 3.2, which is the argue one. If you've already done it, feel free to do something else. And again, what I'm going to do here is I'm going to leave my traffic light one so I don't lose it. I'm going to create a new one. Scratch will temporarily make an untitled one in my account, and I'm just going to file load from my computer. Get the argue script from chapter 3. It's going to replace my untitled with argue. All right, and let's just run it. Now, at the moment, I can see it just bouncing back and forth. No, I'm the cute one. No, I'm the cute one. No, I'm the cute one. And I can only see the code for the cat running. It's highlighted in yellow right now because the script is actively running. So the cat starts things off by saying, I'm the cute one for 2 seconds. And then forever after that, he waits 2 seconds. And then for 2 seconds says, I'm the cute one. Stop it. Who's this guy? Gobo. Gobo, the sprite, has just a forever wait 2 seconds. And then he says, no, I'm the cute one for 2 seconds. Right. So this is synchronized. So let's think about the synchronization here again. We got the cat that immediately says, I'm the cute one for 2 seconds. When I hit the flag, right, he starts saying, I'm the cute one for 2 seconds. Also, when I hit the flag, the forever loop starts for Gobo here, and he waits for 2 seconds, but then he says something, right? So since the cat started things for 2 seconds, Gobo had to start with a 2 second delay so that they switched back and forth. If I change the order of these, it's going to screw stuff up. So I'm just going to run it with that different order there. Right, so now they're not alternating doing it, they're just saying at the same time, and there's a 2 second pause of nothingness in between. Okay, so the point of that right there is a lot of times when I'm trying to coordinate some events in my system of sprites in my program, I have an idea about how I think it should work. And sometimes though my coordination is a little off, or I do things not in the quite right order. And we're going to find that the order at which we do things is going to be a regular pain in the butt when we're programming, and we're always going to have to pause. And sometimes it's complicated enough that I have to write a script on a piece of paper first, then go to my code and make sure my code is following the script on my piece of paper. Okay, now this is pretty straightforward. There's only 2 things going on here. But I think you'll find if you have more than 2 or 3 or 4 things to do in sequence, the order of it's not always going to be straightforward, and you're going to have to play around and figure it out. I don't think we were asked to do much here. Let's see, what does it say? Open it up, run the application. You see an endless argument, study the 2 scripts to understand how they are accurately using time synchronization for the actions of the characters. And that's it. I just wanted you to open up, run it, see how it works, think about the whole order of waiting 2 seconds, then doing something versus doing something and then waiting 2 seconds. Okay. Now, let's take a look at some other stuff. These blocks here look dark purple. What would we call that color? I'm not good with colors. Looks purple, and then sound is what? Violet? Sure, there we go. Okay, so the purple looks is where the say matches the color of, and we have a couple of different options. We have say blank for 2 seconds or whatever seconds, and we just have versus say. What's the difference? I don't know. Let's try. So a lot of times when I'm programming, I might play with options. So I'm going to take out the say I'm cute for 2 seconds. And to do that, I got to dislodge some blocks a little bit. And then I'm just going to copy and paste that in place of the hello, just to see the difference of how the script runs. And then run it and see what happens. Okay, so I screwed it up by doing that. Okay, things don't quite work the same way now. So I'm going to stop it and explore a little more. I'm complicating it by having the forever block there. And I'm going to just disconnect his forever block too. All right, so now I'm just want to isolate. What is the say versus say for 2 seconds? I think it's pretty obvious what it does, but the behavior in the script is something else to see. All right, when I click the flag here, it just says that the script's running. So until he does something else, it's going to keep saying that. Stop the script, put in the forever block. See how it works now. So it doesn't seem at the moment that it's a big deal that I use say I'm the cute one without the timing versus say I'm the cute one with the timing. when it's running by itself. But did you notice, right, when I had Gobo going too, it just wasn't working right? Right. So oftentimes we want the synchronization in there. So again, I'm going to take this off. When I run it, it just says I'm the cute one until that block does something else. In this case, there's nothing after it. So that's all it does. Versus, stop that, pull that, put the 2-second one back in. In this case, when I run it, he says I'm the cute one, and after 2 seconds, it vanishes, regardless of what happens next. Okay, so slightly different behaviors. It is important because sometimes you'll think I just want to say something and not worry about the timing, and then later you realize, oh shit, I should have timing in there. And it just depends on the script. But there are 2 options that you have to play with. Sometimes one is better than the other. In this case, we definitely want it to be that way right there. All right. So again, all you really had to do for this one is open it up. And then I just wanted to play with it a little bit to help you understand what was going on there. All you need to do now is share it and link it. All right, let's see. Is there anything else I wanted to talk about? I'm not having you turn in everything, and I'm going to skip over some things in the book, expecting you're going to read about it on your own. So you're all adults. I believe that you will do that. The graphic effects stuff is pretty cool. Check that out. That's the next example in the book. I am going to skip past that to the size and visibility section. And we are going to take a look at layers, which is try it out 3.4. For try it out 3.4, we're going to go grab the layers script. The try it out right before this is pretty cool too. The sneezing cat. I highly recommend you try it on your own. I'm going to skip it right now and open up layers. Again, if I have argue open right now and I try to open layers now, argue is gone. It's now called layers. All right. So first I'm going to go to new. Then I'm going to go to load and layers. And again, Scratch warns you, right? When you do that, say, hey, we're going to replace the contents of your current script with this one. Every once in a while I say, oh yeah, sure. And then it's like, oops, didn't want to do that there. Okay, so let's see. What do we got going on here for layers? We've got a bunch of different sprites here. And let's see, we've got the click that for the, let's see, let's check out this sprite here. Oh, do they all have the same code? Almost. They're in slightly different positions, but otherwise their code looks similar. What else is different besides they're slightly different? I guess there's a direction that's slightly different. It's their directions that are slightly different. What else is different about the code for each of these? What's that?
Positioning.
I think the position's the same on these. Yeah, I see 2 things changing when I switch sprites in the code.
The letter you have to press.
Yeah, when a letter is pressed, there's the go to front layer. Okay, so that is a purple, so that's under look. So let's take a look at what we have for options there. Okay, down toward the bottom of the look section, we have a couple of things. We have go to, and there's a front drop down layer. And if you've ever played with graphics design before, in a graphics design program, you work with layers, so kind of like a collage, right? You cut things out of a magazine and you can put one on top of each other. Until you put glue down, you can change who's on top, right? Graphics programs keep track of which layer is where in the sequence. So here we have front and back. A simple version of a graphics program is like in Microsoft Word, you can insert a drawing. Google has the same thing. And you can play around with what shape is on top of what shape. And you have options like move things forward, move things back, move to the front, move all the way to the back. So in this case, we can go all the way to the front or all the way to the back. Or we can go forward one layer at a time, or two layers at a time, or so on. Or we can go backward one layer at a time, or two layers at a time, and so on. Okay. So all of these have, when a key is pressed, press a letter, and there's instructions on it, right? Press BOPY to bring one of these shapes to the top. And they don't mean top of the screen, they mean top of all the layers. So I'm just going to run it. And what I should find right now is the yellow one is always on top of the others whenever it goes by them. So if I want, let's see, the sprite 4 to be on top, then I would have to press the P key. Where's P? So now I should see that that one's going to be on top of all the other ones because I brought it to the front, right? Which is different than bringing it forward one layer. So there are times when we're working with multiple sprites on a screen and we want one sprite to be in front of another sprite in one context, but behind another sprite in another context. So the book shows an example of this, and I'm just going to kind of draw it on my other screen here. And, oh, tablet shut off. So if I can reconnect it, you can do it. Come on, come on, come on. Oh, shit. Oh, it connected. Yay. All right, so let's say that I have me on a screen and my stick figure is going to be running around the screen. That doesn't look like running. Let's try that. Oh yeah, that looks good. But the wind flying behind me. And eventually there's this rock in my way. And I want to run, say, behind the rock, then in front of the rock, right? The only way I can make that happen is to make this guy move here. And I want to make sure that the rock is in a layer in front of my guy. But then when my guy turns the corner and comes back this way, right, I then have to change when I get to about that horizontal position right there for the guy to be in front of the rock. Otherwise, he'll be stuck behind the rock, right? So when we have, and again, think about another thing. In this context, I'm going to have two sprites on my screen here. The rock isn't going to be part of the background. The rock is going to be another sprite. Because guess where the background always is? It's always in the background. The background is always at the bottom. So if you have things that want to appear like background stuff, like a rock or a tree, but they need to interact with the characters, then they have to be sprites instead. So there will be some times when we have these elements that you might consider background, like a bush, a shrub, a building, a rock, but they have to be sprites in order for the layering to work right. Okay, so layering only works with sprites. So sometimes we will have a stationary rock. It doesn't move on the screen necessarily, but we need some forward backward layer motion to go on to make the effect on the screen look better. All right. So let's see, what did the try it out asked us to do? It says run the application and explore the effect of the go to front command. Now, note about that, it used to just say go to front in Scratch 2 and Scratch 3, it says go to front layer. They wanted to be just a little more clear. So sometimes you'll see slight differences in the wording on these blocks between Scratch 2 and Scratch 3. Scratch 3, they have the word layer on the outside. Okay. Would go forward one layer have the same effect as go to the front layer? Yeah. It will not, right? It depends on the block, right? If the block I'm looking at happens to be in the second to top layer, then go forward one layer would work, but it's not necessarily the same as go to front depending on the layering going on. Okay. All right, so two different contexts for those blocks, whether you want to move up a layer, back a layer, or you want to go all the way to the front or all the way to the back. And that's with a sequence of sprites. All right, so all I wanted to do there is play around. So I'm just going to shut up for a minute and let you play around for a minute. Once you're done playing with this, then you should share it, get the share link, and then link that share link in your Google Doc.
So I'm having some problems trying to open the files. When I do like chapter 3.
So to open a file, you have to be in Scratch. You can't open it from the computer, so you have to go create. And computer,
Okay.
Got it. There you go. All right, in just a second, I'm gonna move on to, I think, volume demo is next. Question or just stretching? So I'm gonna share mine here. Copy the link. Put it in my Google Doc. All right, next. Let's see, my sound, I can't remember if I set Zoom to have sounds come through. We'll see what happens. So I'm gonna run my volume demo. Okay, kind of cute. The cat moves into the distance. As it moves into the distance, it's saying meow. After each time it says meow, we're decreasing its volume and we're also changing its size. So let's just take a look at the code. We have 2 blocks of code, both say when the flag is clicked. The first one starts the volume at 100%, just to make sure. And then 10 times it's going to repeat, play the meow sound until done, and change the volume by -10. So that should, by the end, 10 times, change by -10, starting at 100, should take the volume all the way down to 0 after those 10 tries. Next one says, when the flag is clicked, make sure the cat's at the position 0 for X, -180 for Y. Set the size to 80% of its original size, and then repeat 100 times. Change Y by 2, change the size by -7/10, and wait 7/100 of a second before doing that change Y by 2 and then change the size. So I have a repeat 100 times. So let's see, it's going to repeat 100 times, 7/100 of a second. So let's see, 100 times 7/100 is 7. So that means the decrease in size is going to happen over 7 seconds. Okay. So the person that made this had to think about the timing of the, now check out the repeat. Does it have any weights in it? Sorry, the volume part. Are there any weights there? No. Sort of. There is and there isn't.
The until done, just place the clip.
Yeah. Yeah, the until done. If you didn't have the play until done, then as soon as it starts to play, the script starts doing other stuff, which means as it's playing meow, it's going to decrease the volume by 10 and then start playing meow at the same time. Okay, so
Which is really annoying.
which is really annoying, yeah. So again, so if we check some stuff out here, we're on the cat. We know that some sprites have other costumes. This sprite only has that one costume. Under sounds, it has a meow sound, and the meow sound has a 0.85 underneath, which should be its duration. I can come here and play it. So it's just under a second of meow that we're hearing there. Okay. So why didn't the person that made this make the code go for 0.85 seconds, in that wait there. I guess when they ran it that way, it just didn't seem to look as good, right? And these are always programs, even though you have a good plan, there's always a bit of experimentation that goes on in programs all the time, okay? Because what you find is when you implement your idea, it doesn't always work exactly the way you thought it would, or given the tools you have, you got to modify your idea a little bit. So here I actually want you to do something, and I would like you to make this just more interesting somehow. So what do we have to make things interesting? Well, we have costumes that we can play with, and you could say, well, the cat only has one costume. Yeah, but you could add another. How could you add another? Well, when you're playing with a costume, you can actually duplicate it and then manipulate the duplicate a little bit. So it's like the original, but a little bit different. Okay. So that might be something you could do to tweak this a little bit. And then you could have the cat change the costume. You could do something like, besides just change the cat's Y position, as this is progressing, you could use some other movement feature. Like, could you get the cat to like wiggle a little bit as he's moving? I thought that would be interesting, because cats don't quite move as still as that one does. Other things you could do is there are other sounds that you could import, and you have the option of recording a sound yourself if you have a microphone at the computer you're at. I don't think these desktops have microphones on them.
And upload sounds.
Yeah, you can upload sounds. Yep. Yeah, so I've had people upload clips of songs that they like. There is also, if you go to the extensions button on the bottom left, there is a music where you can add musical sounds. And there's a whole bunch of different, like, this is basically a mini synthesizer right there. Okay, so you can compose music with this, and you could add some sounds from there. So there's lots of things that you could do to this. So I want you to try something related to sound, costumes, or movement, or all three, or anything else you think you want to try to modify this script. And then once you're done modifying it, you're going to share this and get me the link in your Google Doc. So I'm gonna let you play here for a minute. If you have an idea about something you want to do, but you're not quite sure how to implement it, ask me only after you've tried something. But don't ask me until you've tried something.
Costumes.
And then we've been going at this for almost an hour now. So if you need to take a potty break,
Oh,
please do. And I just noticed I lost my water bottle.
And there's.
Don't forget to bring it. All right, I'm gonna get a drink of water. I'll be right back. Huh. Chats. Wrong minutes. So hopefully you downloaded those files to get this started. And if you get really stuck, which you shouldn't, because I think the instructions in the book are pretty good, the dancing on stage script is already put together. So our goal is to, by scratch, build that. So you have the backdrop, and we're using Dan here. And then I also had extracted the disco ball and that screen in the background as sprites also. And then now it's a matter for each sprite or the stage attaching the right code. So for example, figure 312 here says, use this group of code blocks for the stage. And I mentioned before, we can assign code to the stage. Can the stage do the same thing a sprite can? The answer is no, but there's a lot of things you can program the stage to do, right? So in this case, we're going to program the stage to use some music. And then instead of using the cat sprite, we're using Dan, and Dan has a few different costumes. And so here they're saying, let's see, I think we should have those costumes. I forgot to double check that. Where's my... What does Dan come with? Yeah, so Dan has the Dan A and the Dan B costumes. So our dancing with Dan is really just jumping back and forth, switching his costumes.
To be honest, I kind of just do a couple more costumes and edit them slightly.
Awesome. Yeah, yeah, and feel free to modify these, have fun with it. You can go a little farther than what it does there. So this is the set of blocks that Dan's gonna get. And let's see, I think this is scratch 2 blocks. I don't think there's much difference between the scratch 2 blocks and the scratch 3 blocks. So that should be pretty straightforward. Okay, so he's just gonna move a little bit. We're gonna use the fisheye effect, and we're gonna switch the costume and then the fisheye effect again. And we're just gonna forever have him loop through that. It's gonna be his crazy dance. And then to the disco ball, we're gonna add some effects that, so we change its color. Similar for the stage effect, the board, we're gonna do some changing the effects there. And notice a lot of times when we play with size, when we play with position, usually we reset it when the flag is clicked, right? So like the first thing for the board and for the disco ball is to clear the graphic effects to put it back to wherever it was. Okay, because otherwise it's stuck in whatever state we modified it as if we don't include that in there. And that's going to be a thing we're going to find we're going to do in other ones. So I'm going to let you keep playing with that. And then I'll check in just a little bit.